In this part, we are going to talk about things that we can do at the point where the target is parsed, which is basically read or change the state of the target program. By state we mean the contents of the registers or the memory. We are going to see how to change or read the contents of the memory or the registers at the point where the target program is parsed. Let's begin with the first program, increaser.ascend. We describe the contents of this source file. We can see here three sections. The first one is the data section, then the BSS section, and finally the text section, which contains the code. In the data section we can find an array of dwords, which is called source list. It contains a few predetermined dwords, which are those dwords. There is also a constant defined here. It is called list_len. We use this $sign for a special calculation. We calculate the size of source list by taking the address of the current location minus the label source list, and finally we divide by 4 to actually count the amount of dwords. The BSS section also contains an array of dwords. This array of dwords is exactly of the same size of source list. It is of size list_len dwords. The text section contains a few instructions. Basically, it is really made of a loop and a few instructions for initialization. The first 3 instructions initialize ESI to be the address of source list, EDI to be the address of dest list, and ECX to be list_len, which is the amount of elements in any of those lists. Next we have this loop. Let's see what happens in every iteration. First we read a dword from source list. Then we increase that dword and we print it to the console using the print_eax function. Next we store the new value, which is the increased by 1 dword, into the destination list. And then we move on to the next iteration. Basically it means that every dword of source list is going to be stored inside dest list, but it will be first decreased by 1. And at the same time, each dword which is stored inside dest list will also be printed to the console. We expect to see the following values printed to the console: 2, 6, 9, 3, and so on. Let's save this file, assemble and run it, just to make sure that it works right. We get this result, and as expected, every dword that we see here is just one of the original dwords in source list increased by 1. We have 2, 6, 9, 3, and so on. Let's open increaser.exe with WinDBG. I open WinDBG, the x86 version. Let's resize it a bit. And then I'm using the file menu, open executable. I could also use Ctrl+E. Next I have to supply an executable file, which is going to be increaser.exe. Let's copy this path and now I pick increaser.exe. We got here increaser.exe in a paused state, and we have the debugger window. The first window that we get is the command line. Let's maximize it and start working. I begin by putting a breakpoint on the entry point so that I can use the go command to get to the beginning of my code. I continue with the go command. At this point, I got to the first instruction of my code. Let me show you the similarity. This instruction that we can see here, move ESI, offset, and some other things, is exactly this instruction. Move ESI, source list. We want to see a few more instructions, so let's open the disassembly window. View, disassembly. Next we clip this window. Now we can see more instructions. Let's compare it again. Move ESI, source list. Move EDI, dest list. Move ECX, list len. Those three instructions exactly correspond to those three instructions. Move ESI, some offset. Move EDI, some offset. And then move ECX, none. By now you probably have seen that the syntax of the assembly inside WinDBG is a bit different from the FASM syntax. You shouldn't really worry about this. Instructions are just instructions, and they are the same in every syntax. Let's start stepping to see what happened inside this code. Currently, we are only on the code of initialization, which are the first three instructions. Let's step over those three instructions. I'm going to use these buttons from the graphical user interface, but you instead could use the shortcut. The reason for me to use those buttons is just to make sure that you see which command I'm going to use. At this point, step into and step over are mostly the same. It doesn't really matter which one I pick. I step over those three instructions, and I get to the first loop instruction, which is load s. This instruction is currently marked, which means that it hasn't executed yet. Only the first three instructions has executed. Also note that some strange things has happened inside the disassembly window. For example, we cannot see the first move ESI source list instruction. The disassembly window is not perfect. Sometimes it will not parse the code exactly the way which you expect. We will soon see other ways to look at code. At this point, we know that ESI has the address of source list, and that EDI has the address of dest list. We also know that ECX contains list len. We might want at this point to view the values of those registers. Maybe we want to know, for example, the value of ECX or EDI and so on. We could do this using the R command. Let me do it again. The R command gives us this output. This is a lot of information. We can see the values of all the registers and also the current instruction, which means the next instruction to be executed. We even have the values of the flags. If you ever want to view the value of only one register, it you could supply the R command with an appropriate argument. For example, if we want to view the value of ECX, we could use the command RECX, which shows us that the current value of ECX is 9. We could also view the values of ESI and EDI. I remind you that ESI points to the beginning of source list and EDI points to the beginning of dest list.